right, let's get going. So these are all the laws of exponents that we have done so far. Okay. These are all the laws. I am not sure at your school if you will be required to write next to it which law you're using. Okay. So we're just going to learn them properly in order and know which one is what. So law number one, just to recap, was the multiplication law. So if we were multiplying powers with the same base, we added the exponents. Okay, so that was for multiplication. No, my color coordination is terrible. All I see is yellow. There we go. Multiplication means add exponents. And then when we were dividing powers with the same base, we subtracted the exponents. Okay, so the opposite, inverse operation for multiplication and the inverse operation for addition. Right. Then for law number 3 and 4, we had a combined sort of lesson, right? Where we said law number 3 was if you have a power to a power. So I have a to the power of m, and I'm raising all of it to another power of n. In that case, then we are going to be multiplying the exponents. And then finally, for law 4, it is the distribution law, which is just the extension of law 3. Okay, this time we have two different bases, but we still take that guy on the outside and we multiply it with every single exponent on the inside. Okay, so this is, you guys can take a screenshot of this so that you have a summary of all your laws in the same place. So you can refer to them. Okay, so even when you're studying, even when you're practicing, you can refer back to the summary of the laws. These are the 4 laws of exponents. All right. Now, let's get going with some interesting work here. Let's get started with this one. Okay, let's warm up our brains a little bit. This will be our number A. Where do we start with number A? Where are we going to start with number A? Distribute, says Seth. What does everyone else say? We have a healthy attendance over here. So I want to hear what everyone else says. Distribute, says Laura. Says Roa. And as you guys are sending those distributes, I'm going to write something here. Is anyone going to change their answer? Guys, distribution is way on the bed mess. Where does distribution fall in? Where does distribution? It falls in the E. Thank you very much, Londeka. Distribution falls in there, right? But now we have skipped brackets. Is there anything inside the bracket that we can simplify? Remember, that's where you always start. Yes, so we are actually supposed to start inside the bracket. Is there anything inside my bracket that we can simplify? Yes, there is. So let's do it, okay? 4 and 16, do they have a common factor? Oh, nice. Already, 4 goes into itself once and into 16. 2 is also a common factor, Tlali. It is also, but the highest is 4. Okay, 4 goes into 16. It's not twice. Check again. 4, 8, 12, 16. Okay. There we go. There we go. Okay, so it's 4 times. So now we run. Is it necessary that I write the 1 at the top there? You guys think it's necessary for me to write the 1 at the top? No. So let's look at my other bases. I have an X and I have a Y. We are dividing. So what do we do with my exponents? We subtract them. So I'm going to have X to the power of 5 minus 1 times Y to the power of 1 minus 4 all over 4. And this is still all raised to the power of negative 3, right? Now let's simplify this. X will be to the power of 4. My Y will be to the power of negative 3. And at the bottom is just the 4. And there we go. Now where do we go with the sum? We have simplified stuff inside the bracket. So now where do we go with the sum? Distribute. Nice, Seth. Thank you. We're going to take this -3 guy on the outside and we distribute him to everyone. X, Y, and the 4 at the bottom. Okay? So then I'm going to have x to the power of what? When we distribute, what do we do again with our exponents? We multiply them. Thank you. So it's going to be x to the power of 4 times -3, y to the power of -3 times -3. And at the bottom, I'm going to have a 4 to the power of -3 because there was just the 1 there. Okay. Now I'm going to insert a little page divider here so we have space on the side. And that equals, what is 4 times -3? My exponent for x will be -12 times. My exponent for y will be, oh, you guys are answering at the speed of light and I love it. It will be 9. And at the bottom, it's just a 4 to the power of -3. Now we have a problem, a big problem with these negative exponents. How do we fix that problem? How do we fix the problem with the negative exponents? Anybody? Put it in fraction? Not quite. They are in a fraction technically, right? So what do we do? They switch, right? Yes, use the negative law. Okay, be careful of saying swap. Careful of saying swap. You must say we move them. Because remember, if x was the only one that had a negative exponent, we would only move the x. So I'm scared of using the word swap because that means every single time we are swapping. And that's not what we're doing, okay? So my x to the power of -12 will go to my denominator. And my 4 to the power of -3 will go to the numerator. And once they swap, or once they move, I just said don't say swap. Once they move, then I have positive exponents. So we're going to have 4 cubed times y to the power of 9 over x to the power of 12. How much is 4 cubed? How much is 4 cubed? 64. Thank you, Kirini. And in Claire, in group 2, y to the power of 9 over x to the power of 12. Nice. I hope our brains are warm. Thumbs up, thumbs down. Do we understand everything we did there? Give me a thumbs up or a thumbs down. If you're new, go to reactions if you want, or you can just send it in the chat. I think you just hover over your name and then there's a place where you say more. Then you change, you say rename. Okay. You say more, then rename, then you should be able to rename yourself. Let me know if that works. If not, you can DM me your name. I'll rename you. And then, yeah, we'll be sorted. Okay, wonderful. Those are a lot of thumbs up. I like them. I like them. Okay. I have a lot of stuff for us to do. I was taught to times the negative exponent by 1. Then move it up or down, depending on where the negative exponent is. Yes, Arian, that is what I am saying, right? But all I meant when I said be careful of saying the word swap is, let's say I have y to the power of -2 over x squared, right? We are not swapping them. This x is not going to move to the numerator. Okay, we're not listening. We're looking at the question. So what I was saying is, these are not swapping. It's just the y that has to move to the bottom. But you are timesing it by -1 in order to make your exponent positive. Okay, so then after this, what will be left in my numerator in this case? my y moves to the denominator, what is going to be left in the numerator? A1. So it's 1x squared y squared. Doesn't matter where the y goes. We typically write them in alphabetical order. Okay, x, y. If there was a z, it would come after that. Okay. So that is a good question. We usually write them in alphabetical order. So just think, we usually don't say BAC when we're doing algebra. We will write it in order. So it'll be ABC. Okay. So I hope you guys understood what I meant when I say we don't say swap. We are moving the ones with the negative exponents. Nice. Maya has renamed. Okay, now I go to this. First one, true or false? Okay, let me go back to my first answers. Oh, Spamandla said false and Seth said true. Lwandeka says true. Senyane says false. Ooh, we are pulling each other all directions. True, false, true, false, true, false. Okay. All right, guys, what does law number 1 say? We are multiplying here and we have the same bases, right? We are multiplying and we have the same basis. So thank you, we're supposed to add our exponents. Do we do anything with those bases? No, you keep the base. So it's actually 5 to the power of 5. In this case, what did they do with the bases, guys? How did they get 25 over here? They multiplied the bases. And are we supposed to do that? No. So is this in fact true or false? Nice, guys. This is false. Nice, 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 nice. Okay, let's look at number B, true or false. Let's hear what everyone has to say about this one. Okay, Angel says true. False, false, false. Oh, we have false. Okay, I saw one more true there somewhere. Ronella said true, but everyone else is sticking with false. Kireni also said true. Laura says true. Okay, so guys, let's think about the law number 4. Okay, that is the law of distribution. So if I have A times B in a bracket, all raised to the power of 2, what am I supposed to do with this 2 on the outside? What am I supposed to do? I distribute, right? So then I'll be left with A squared times B squared. Does anyone see where I'm going with this one? Let's look at what we have. Okay, this is law number 4 going backwards. So we have 2 different bases, just as we do here. We have an A and a B, but we have the same exponent. Do you guys see that? So that means this question started off over here, except this time my exponent was a 3. Do we see so? Oh, the chat went very quiet just now. So you guys see it. We see it. So this is law number 4 going backwards. So therefore, I can then say, then if I had those 2 bases inside all raised to 3, can I not just multiply those guys on the inside? Tali, I'll be with you just now to re-explain. Can I not just multiply those guys? Yes, it's going to give me 10 to the power of 3. So is this true or false? This is true. All right. So we're at a very important milestone here. Ooh, why can't we add our exponents, guys? Yes, Maya, your hand is up.
Ma'am, yeah, I wanted to ask that question. Why can't we add our exponents?
We only add our exponents when?
Ma'am, is it not during multiplication?
But look in the chat. There's one condition
Oh,
for
when the bases are the same. Oh, okay.
Oh, do you see? So this
Yes, ma'am.
case forces us to do the reverse for law number 4. If they were both bases of 2, we would just add the exponents. But in this case, the exponent is the same, not the bases.
Okay.
Here we go.
Thank you,
All
ma'am.
right. You're welcome. You guys are asking very intelligent questions. So in this case, we cannot add our exponents because my bases were not the same. But I can take the same exponents that was there, take it back out. So I'm going in the opposite direction of this law. I'm going that way. Okay? And then I can be left to multiply those bases. Tali, you were a bit confused earlier. Are you cool now? Hopefully Tali is with me now. Okay, that was an interesting one. Okay, wonderful. Wonderful, wonderful, wonderful. So don't be trapped by such questions, guys. Check if the laws that you are working with are not inverses of current laws. These laws work front to back, back to front. Okay, so the law I was talking about now is law number 4. It's this one. You see? We had two bases, a to the power of n times b to the power of n. So I've just gone backwards now and I took out the n and I multiplied those guys inside. All right. Now, let's talk about the interesting stuff here. What can you guys tell me about number 1? It says simplify the following. We're going to simplify this. Now tell me, where am I going to start here? What is the problem with what I currently see? As is, can I do anything with the sum as it stands right now? Deborah says yes. What can we do with the sum as it stands? What do you guys suggest we can do with the sum as it stands? Seth says multiply. Are we allowed to multiply bases if they do not have the same exponents? No. It's fine, Seth. I like suggestions. Oh, Tebogo is onto something there. Tebogo, what are we changing the bases to? Tebogo is onto something beautiful over there. Oh, guys, can we rewrite 27 and 9 as something with the base of 3? Yes, Pamandla?
Ma'am, put them over, do we put them all over 1?
No, that's not going to
Because they're
change.
on.
Right? It's just going to be 27 over 1. And then we can't do anything about it. You see? But you guys said we can change all these guys to have the same base. Because if they had the same base, then we would apply our laws. Now let's change them. No, we're not dividing by 3, Umpa. You're not allowed to change the numbers. But we can change them. Okay. Nice. 27 is the same as 3 cubed. So I'm just going to write it in brackets and rewrite my whole exponents the way it was. And 9 is the same as 3 squared. Whew, I love it, guys. X minus 1. Do we have to change the last one? No, it's already a base of 3. 1 minus 5x. Okay, I'm going to stop right there and take a thumbs up, thumbs down, and try to find anyone that I may have lost on my way here. What we have done so far in the sum is everyone with me. I only have 7, 8 thumbs up. And we are 32 today. Seth, I've lost you. Let's talk, Seth. Where did I lose you? Do you want to raise your hand or do you want to just send in the chat? 3 cubed. Okay, Seth. So I want the same base, right? But now I have a problem because I have a 27 and a 9 and a 3. Okay, our best bet to get the same base here is to make them the lower base because there's no way we're going to write 3 as a 27 base. Okay, so I asked you guys, how can I change 27 to a number that has the base of 3? And they said 3 cubed because that means 3 times 3 times 3, which is indeed 27. Did you see how we got there? Maya, I see your hand. Don't put it down. Are you feeling much better now? Hopefully we are. Wonderful. Yes, Maya.
Ma'am, okay, this is a dumb question, but I wanted to ask, like, when do we know what to do when? Like
You
in this
practice.
case. No, like,
You
ma'am, in
practice.
this, is there like a rule for everything so that you can like identify what to do when?
Charlie has a nice suggestion. I mean, in this case, if the bases were not the same, right?
Yeah.
Is there
Yes, ma'am.
anything else that we'd ever be able to do?
No.
We'd be stuck. Do you agree? Like you can't
Yeah.
apply your laws. You can't, there's absolutely nothing you can do. So you have to change that. But if you guys know your powers well, for my learners, I suggest that at the back of their books, they learn their powers. So they'll learn like 2 squared, 2 to the power of 3, 2 to the power of 4, 2 to the, so that you recognize it easier. So that as soon as you see a 2 and an 8 and a 16, you know that those are all powers of 2. So immediately your brain is like, let me change all my bases to 2, and then it's easier to work with. Do you see?
Okay.
Yeah. But I mean, it depends on the question. For instance, if I have 2 times 4 like this, do I have to do all of this?
No.
No, I can just multiply it, right? But in this case,
Yeah.
we have exponents of x. We have no idea what x is. So you have to change the bases.
Okay. Okay. That makes sense.
Don't worry, don't worry. Practice. Tlali, I see your name, your hand is up. Yes, Tlali?
I wanted to ask that, ma'am, what would you do if, let's say, it's 18, it's 18x plus 1, 3, 1 minus 5x, and then 5 to the 5 to x.
Okay, there's a lot going on. 18x plus 1, and then
Ma'am,
plus.
like
Am
the x, the x plus 1 is an exponent.
oh, I'm so sorry. I'm so sorry. X plus 1. Sorry. Yes.
Times
Mhm.
5, 2 plus x.
Like so.
Yes, ma'am. Times
Mm-hmm.
6, 3 plus x.
Like so.
Yes.
Okay, so Tlali, remember I said you can take those laws backwards. You remember that.
Yes, ma'am.
So, in order for me to add these exponents, what was I supposed to have been doing before? In order to add exponents, what are you doing with the powers? You are not dividing them, you are
Adding,
look in the chat. Min is helping you.
multiplying.
Multiplying, because the law says when you're multiplying, you add the exponents. You agree with me?
Yes, ma'am.
Okay, so do you see that you can split these up? So instead of 18x, you can have 18x times 18 to the power of 1 times 5 to the power of 2 times 5 to the power of x times 6 to the power of 3 times 6 to the power of x. Do you see what I just did?
Yes, ma'am.
Split them all up. Now we want the same bases here. And we have to go back to prime factors. Do we remember those things, guys? Where you had to do the ladder and it was 2 times divided by 2 divided by 2 divided by 2. That's what we have to go back to now. So 18, okay, there's a way we can do it with a calculator, but Tali, you're a little bit ahead now. Okay, we're gonna
No,
do
ma'am.
these.
Ma'am, I'm asking because, ma'am, what if it comes up?
Are you writing? It's not gonna come up today. We're gonna get there though.
No, ma'am, I'm not writing about it, but ma'am, the question popped in my head. Let's see, what do you
Okay.
do if
Okay, so you're gonna change these to prime factors. Do you know that you can make 18 to the power of 2 times 3 squared? And this
I
will also be 2 times 3 squared, and then a 5, and then 6 is 2 times 3. And then you see we end up with same basis, a 2 and a 2 and a 2. So you're going to add their exponents. A 3 and a 3 and a 3, you're going to add their exponents. And then the 5s, you're going to add their exponents. And eventually they cancel out, and you'll be left with a simple answer. But we're still going to get there. Remember, this is just starters, okay?
yes, ma'am.
There we go. But it seems like a lot of us remember this in the chat, which makes me happy. Go revise your prime factorization. Okay? Go revise your prime factorization. So to answer Entle, no, we are not solving for x. All right? We're not solving for x. Remember, solving for x means we're going to end up with the answer that says x equals something, which is not what we're doing here. We're just simplifying. Okay, so now I have my basis of 3, and we have power to a power. What does the law of power to a power say? These guys. What am I supposed to do with these guys? Okay, Tebogo says get rid of the bases, which is valid, but we distribute. We distribute. We multiply them, so we're going to have to distribute, because technically what we have is 3 times x plus 1. Can you guys see that? And over here, we have 2 times x minus 1, like so. Okay, I just thought about what Tebogo said. We can't get rid of the bases, Tebogo, because we don't have a left and right hand side. So the bases can't just vanish. Okay, you guys are going way too ahead. Hold on to your horses. So I'm still going to keep my bases, 3. And the first one is going to have the exponent of what? If I'm distributing. We're going back to algebra here. There we go. There we go. So it's going to be 3 to the power of, for my first one, 3x plus 3. Thank you. Times, for my second one, it's going to be 3 to the power of, we're over here now. Nice. 2x minus 2. And the last one, I'm just going to keep it as 3 to the power of 1 minus 5x. Beautiful. Now we are multiplying times. Everyone has the same base. So what do I do with my exponents? I add them. So I'm going to keep my one base. I don't need all of them. Then I'm going to have 3x plus 3 plus 2x minus 2. Because it was already to the base of 3. We didn't do anything. Look at the question. Remember the others we changed to bases of 3. But the last one was already to the base of 3. So we didn't actually change it. So this one is for the first one. And then we said plus the second guys. And finally, plus the third one, which was the same since the start. Now, let's add. Can I just add everything? Can I just say 3x plus 3 plus 2x minus 2, blah, blah, blah? No, what am I looking for? What am I looking for? Like terms. So give me my like terms. 3x is like terms with what? 2x and negative 5x, negative 5x. And then, of course, my numbers will be like terms. So I'll have a 3 minus 2 plus 1. Okay. So then what's 3x plus 2x? 3x plus 2x. 5x minus 5x. 0. So the x's are gone. Do you guys agree with me? The x's have now vanished. Yes. So let's move on to the numbers. 3 minus 2 plus 1. 3 minus 2 plus 1. It is 3 squared. And what's 3 squared, guys? It is 9. All of that's just for the answer to end up being 9. Okay. Thumbs up, thumbs down on this whole entire sum. How did that go? Are we with me still? Tebogo was miles ahead. Well done, Tebogo, for getting this answer long ago. Yes, Londeka? I think you may unmute yourself. Londeka, you can unmute. Oh, it's a mistake. Oh, lower hand. Andile, where did I lose you? Where did I lose you, Andile? Oh, but Andile, you must stop me at the start. You can't let me finish the whole sum if you're lost. Okay. So in the first step, we changed everything to have a base of 3. Do you understand that part? So 27 is the same as 3 to the power of 3. And 9 is the same as 3 to the power of 2. Are you with me so far? So all we did was change them so that they have the same base. Wonderful. But now we had power to a power, right? We had a 3 cubed to the power of x plus 1. And the law of power to a power says, what do you do when you have two exponents? What do we do when you have two exponents? We multiply. Thank you, Seth. Andile, are you with me? We multiply. But now this is not so simple and straightforward because these are two terms. You're multiplying a monomial with a binomial. And how do we do that in algebra? How do I multiply one term with two terms? I distribute. So you multiply 3 by x, and then you multiply 3 by 1. And that's where the 3x plus 3 comes from. Because 3 times x is 3x plus 3 times 1, which is 3. You see? And then we did the same thing with the second one. This time we had a 2 times x minus 1. We are distributing. So you have 2 times x, which is 2x, minus 2 times 1, which is 2. So you with me so far? Wonderful. And then we were left with the same base. Okay, now we're over here. We have bases of 3, and we are multiplying. These dots means multiply. And law number 1 says, if you are multiplying with the same base, what do we do with my exponents? Law number 1, we add them. So that's what I did. I said 3x plus 3, which is the first one, plus 2x minus 2, plus 1 minus 5x. So I'm pretty sure that one you understand. And then we looked for like terms. That's why I highlighted them in different colors. Because remember, you can't just add x and a number. Okay, so my like terms were 3x plus 2x minus 5x. Now what's 3x plus 2x? 5x, and then if you subtract 5x, it is 0. So the x's have actually vanished. Do you guys see that? So I moved on to my numbers. I said 3 minus 2, which gives you 3 minus 2 gives you a 1, and then plus this one. gives you 2. So that's why I was left with 3 squared. Then I just solved it. 3 squared is 9. Did I find you, Andile? Are we good? Hopefully, wonderful, wonderful. I know there are some people who might have needed that, some other people. So well done for being brave and speaking up. Okay, but you guys must stop me as soon as I lose you. You must be like, ma'am, that step didn't see what happened so that I cannot confuse you further. All right, we're going to do another one. We're going to do another one. And if you remember what we just did, what are we going to do in this case? As it is, can we do anything with the sum? As it stands right now, Kali says yes. What can we do with the sum, Kali? And Andile and Nelson? Oh, everyone's saying times. Am I allowed to times when there are exponents there? Am I allowed to say 2 times 4? Be careful. No, I'm not allowed to do that. Okay, so I cannot times my bases. I also cannot divide my bases. So what do I do? Kali, what do you mean separate? Oh, Senyani has said it. Okay, so this is what I was talking about recognizing your bases, recognizing your powers. If you know your powers of 2 well, then you know that 4 is the same as what? I'm going to rewrite 2 to the power of x. Nice. 4 is the same as 2 squared. Okay, Tali, I see your hand. Yebo.
Ma'am, I wanted to ask, ma'am, what I meant by separate numbers, like I say 2 multiplied, 2 to the power of x multiplied by 4 to the power of x plus 2. And then I put the sign of division. And then after putting the sign of division, and then
Put the
8x plus 3. And then I put it to the same base.
Oh, I see what you
Yeah.
meant. So you write them next to each other, not. Okay, I see what you meant. Thank you for clarifying. All right, guys. And then 8 is, thank you, Senyani. 8 is 2 cubed. This is all raised to the power of x plus 3. Now, the 2 to the power of x, I can't do anything about, so I'm going to just leave it as 2 to the power of x. Once again, we are stuck with power to a power where we have a monomial and a binomial. So we're going to do what? Distribute. So this 2 will be multiplied by the x and the 2. So then it's going to be times 2 to the power of 2x plus 4. Thank you. And at the bottom, I'm distributing the 3 this time. This 3 has to be distributed. So I'm going to have 2 to the power of 3x, yes, plus 9. Beautiful. Okay, now where do we go from here? Where do we go from here? We are only multiplying and dividing, right? So this should be a pretty easy sum for us now. Where do you guys think we go from here? Multiply first. Okay, let's multiply in the numerator first. When you are multiplying, what are we going to do with my exponents? I'm going to add them. So in my numerator, I'm going to have 2 to the power of x plus 2x plus 4 over 2 to the power of 3x plus 9. Okay, let me put a little page division here so that you guys can see. If I can find the page division, there we go. Bloop. All right. And this will be, what's x plus 2x plus 4? Nice. So it's going to be 2 to the power of 3x plus 4 in the numerator over 2 to the power of 3x plus 9. Now we're only left with division, which is very important because I want to see what you guys are going to say I must do here. Okay, we are dividing. Same base. So what do we do with my exponents? We subtract. So 2 to the power of 3x plus 4 minus, so I'm going to put brackets. Why am I putting brackets there? Does anybody know why I'm putting brackets this time? What is that minus going to do to my terms? Anyone? What is this minus going to do? This guy. I have to distribute it, isn't it? So it's going to change my... What is it going to change? Nice, my signs. So we need to be careful with minusing, okay? Does a plus change signs? If you're multiplying something with a positive, will it change the signs? No, I mean, if you're multiplying something with a positive, will it change the signs? No, it won't. But when you're multiplying something with a negative, will it change the signs? Yes. So you must be very, very careful. Okay, so this is actually 2 to the power of 3x plus 4 minus 3x. And what's my last term? Okay, I'm coming back to you just now. Minus 9. Who said I lost them? Marlene, do you want to raise your hand so I can unmute you? Or do you want to type it in the chat? Okay, I've already asked you to unmute. Unmute if you're comfortable, please. There we go.
Hello, ma'am.
Oh,
So, ma'am, you lost me by the second this step here. Yes, ma'am.
this one. Okay,
Yes, ma'am.
so Marlene, we are dividing. So you agree we're going to minus, right?
Yes, ma'am.
We're going to minus exponents. So the reason you have to put the minus outside the bracket, Marlene, is because you're minusing the whole bracket. This is actually a negative 1 outside the bracket.
Oh, okay.
So it's like 3x plus 9. What is that negative? A negative times a positive is going to give you
Negative.
negative 3x, and again, negative 9. Look what happens if I don't put brackets. When I end up writing minus 3x plus 9. Is that correct?
No.
You see why I have to put those brackets there?
Okay, thank you.
You're welcome. Okay, guys. You guys are begging for a brain break. I'm not done with you guys. Just give me a moment to finish off. Your brains will break today. I'm kidding, guys. I'm kidding. The brain break will be here soon. Hello, Njabulo. Okay, let's go to our final step. Like terms are both my 3x's. What's 3x minus 3x? 0. X again has vanished. And what is 4 minus 9? 2 to the power of negative 5, which I can rewrite as a positive exponent as 1 over 2 to the power of 5, but I can solve 2 to the power of 5, so I'm going to rewrite it as 1 over what's 2 to the power of 5, beautiful people? No, remember it's not times. It means 2 times 2 times 2 times 2 times 2. 32. Woo! Your brains. This session is ending in about 10 minutes. Okay, I saw the question in the chat somewhere. All right, guys. How was that one? Let's have a thumbs up, thumbs down, and then I'll give you guys a brain break. Thumbs up, thumbs down. Oh, I have quite a bit thumbs up, actually. Remember, if you don't understand, don't be shy to say thumbs down. Okay, that's why we're here. We're here to learn. You guys are boosting my Simtandil is like my brain is okay. Do you guys want to do the brain break now or at the end of the lesson? Andila suggests we just do the next one. And then whoever does want to be part of the brain break can go. What do you guys think? Let's just do the next one, guys. You're just checking if the rules are correct or wrong or not. That's it. Okay? You're just checking. It's one of these. Okay? What is wrong with these? A. Is A correct? No, because when you times, you're supposed to. See, I'm cooling off your brains. Don't worry. You're supposed to add the exponents. So it's actually supposed to be 2 to the power of 3 plus 4, which is 2 to the power of 7. Done. See, guys, they're not that bad. Let's go to B. What's wrong with B? What's wrong with B? They multiplied when they were supposed to do what? Add. Is the answer wrong, though? Is the answer wrong? 3, 4, 5, 6. They just got lucky. What do you guys think will happen if you do this in a test? What do you guys think will happen if you get lucky and you use the wrong method, but you manage to, thank you, no marks. No marks. It means you have no idea what's going on. I will absolutely give you a 0. It was pure luck. Hi, Njabula, I see you greeting me. What's happening? Yes, you will lose marks, guys. Number C, they did the same thing, didn't they? They multiplied exponents instead of adding. So it's actually supposed to be 3 to the power of, for number C, 5. Nice. Number D is a little bit different. They multiplied the bases with the exponents, isn't it? So they said 5 times 3. That's 5 cubed means 5 times 3. No, it means 5 times 5 times 5. You guys agree? So what actually is the answer for number D? It's 5 to the power of 5, which is there anyone with a calculator? We haven't been simplifying, guys. This is terrible. It's fine. We don't have to simplify it. We just have to know exponents. Now let's look at number E. A lot going on there. Number E is very interesting. You guys agree? Okay, let's first start inside the bracket. What happened there? What went wrong? We have 3 cubed plus 3 squared, or raised to the power of 2. Is that correct? They added the exponents. Are you allowed to add the exponents? No, the only time you're allowed to add the exponents is when you are multiplying. So they were supposed to do what with those 3s? I saw someone say it. Oh, are we allowed to distribute? No, we're not allowed to distribute, but we can simplify this, right? By just solving it. Are we allowed to add bases? Oh, there's a lot going on here, guys. Are we allowed to add bases? No, 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 no. Just simplify. What's 3 cubed? 3 cubed, 27, plus what is 3 squared? 9 all squared. What's 27 plus 9? 36 squared, which is how much? 1296. Definitely not 59,049. Ooh, did your brains cool off?